Okay guys, we're gonna review Gemdas and do some advanced problems with Gemdas, and then we're also going to do some of those converting algebra words to algebra expressions, or changing the words to look like math and numbers. So put your date as 9/5/2012, and we're covering Gemdas, or these could be your notes, okay, from home. Alright, and so everything that I write down, you want to write down. I want good steps. So I'm going to start with something easy. I'm going to start with, I'm doing some problems on page 14 from your textbook. So the first problem that I'm going to do is number 8 on that page, and the problem is 1 plus 5 squared divided by 50. And I want to walk through the steps of this problem with you. So make sure that you always copy your problem down from your book. And now we're going to remind ourselves that we are following the rules of Gemdas, okay, the order of operations. And so we have grouping symbols first, but in this problem there are no grouping symbols. So I'm going to cross it off, and I'm going to deal with exponents. Now, to deal with my exponents, I have to leave this number 1 alone, my plus sign alone, and I get to deal with this exponent. 5 squared is really 5 times 5, and 5 times 5 is 25. So I'm going to write 25 in here, divided by 50. Leave the rest of my problem alone. The only thing I solved in this first step that I did is that I dealt with the exponents. I'm done. So I'm moving on to multiplication and division in a left to right fashion. So I cannot touch this addition sign. I have to do my multiplication and division first. So I'm going to write 1 plus, and now I'm doing 25 divided by 50. Well, 25 divided by 50 looks like this. It also looks like this, okay? And either way, it doesn't matter. So you can either put it into a decimal or you can put it into a fraction. So I like fraction form, and I'm going to say 25/50ths is really equivalent to 1/2, because 50 is really 25 times 2, and then I have an equivalent form of 1. And so I'm left with a 1 in the numerator and a 2 in the denominator. So I have 1 plus 1/2, and 1 plus 1/2 gives me 1 and a half. And I can leave it like this, or I could write it as a decimal if I wanted. Okay? And if I had done the long division here, I would have said, okay, 50 doesn't go into 25. So it goes in 0 times. Put my decimal, and now I need to get some zeros. So 50 goes into 250 how many times? We'll count by 50s. 50, 50, 100, 150, 200, 250. It goes in 5 times. And I can just double check by saying 5 times 0 is 0. 5 times 5 is 25. Subtract, I get a 0. So 0.5, and that's where I end up with 1 plus the 0.5. Okay? My next problem gets a little bit harder. So I'm going to throw in some parentheses in there. 12 times the quantity, 6 minus 3.5 to the power of 2 minus 1.5. Now notice, not only do we have parentheses and exponents, but we also have decimals. Okay, algebra is all about decimals. It's all about fractions. So we're going to start by solving this problem. I'm going to write Gemdas off to the side so I can remember my steps. And I'm going to say, all right, I can't do anything with this 12 yet. I have to solve my parentheses first. So in order to solve my parentheses, I have to do 6 minus 3.5. And remember, when we're subtracting with decimals, we line up our decimals. So I'm going to borrow and say 10 minus 5 is 5. Bring my decimal straight down. 5 minus 3 is 2. And so I end up with 2.5 inside this parenthesis. To the power of 2, that still has to stay, minus 1.5. And now I have to solve my exponents. I'm done with grouping, so I'm on to E. So I need to do my exponents. My exponent is 2.5 squared. So that means I need to take 2.5, and I need to come over here, and I need to multiply it together. So I'm going to say 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 2 times 5 is 10. Here in my 1. 2 times 2 is 4, plus 1 is 5. Going to add, and I need 2 decimal spaces, so I should get 6.25. So I have 12 times 6.25 minus 1.5. And I am now done with my have to do my multiplication in a left to right fashion. So 12 times 6.25, well I have my 6.25 here, so I'm just going to write times 12 under it. 2 times 5 is 10, carry my 1. 2 times 2 is 4 plus 1 is 5. 2 times 6 is 12. And save my placeholder. 1 times 5 is 5. 1 times 2 is 2. 1 times 6 is 6. I'm going to add them. And I get 7,500. But remember I had 2 decimal spaces, so I need 2 decimal spaces. 1, 2. And my number is 75. So I get 75 minus 1.5. And now I have to combine my 75 and my negative 1.5, so I'm really subtracting 1.5 from this. Okay, so I'm going to borrow, and I end up with 10 minus 5 is 5. Bring my decimal straight down. 4 minus 1 is 3. 7 minus 0 is 7, and my answer is 73.5. Okay, now I would like you to try one. This is problem number 18 in your textbook on that same page, page 14. Okay, and I'd like you to try 8 times the quantity 20 minus the quantity 9 minus 5 squared, end of that first bracket. Okay, give yourself a chance to try it. If you need to pause now, pause. Then check your work next to mine. So I am leaving my outside bracket alone because I have to solve the innermost part of this problem. So 9 minus 5 is 4. It's going to be squared. And I'm going to say that I have to square it before I can do the 20 minus the 4. So I'm going to leave my 8 and the bracket and the 20 alone. 4 squared is 16. And now this bracket is just another type of a parenthesis. I got rid of my inner parentheses, got rid of my exponents. Now I can do this other bracket. There was no way to do this parenthesis here without first doing the exponent. So that's why I went to my exponent. 20 minus 16 is really 4, and 8 times 4 is 32. So you should have gotten an answer of 32. Now this gets a little tricky. I'm going to do one more for you. It gets a little tricky when you have some variables and you're plugging your own things in. So I'm going to do a problem. This is problem number 30 on page 14, and it says b to the cubed minus 21 over 5b plus 9. Okay, and my b value is equal to 3. Okay, but we're going to solve it a second time, and we're going to do b is equal to negative 3 and watch what happens. Okay, so the first time that I solve it, I'm using b is equal to 3, and I'm going to say that I'm going to plug in my 3 for the b, so I'm going to rewrite my whole problem and say the 3 cubed. And notice I put the parentheses because that's really going to help me when I plug in some sort of a negative number. So I'm going to put my 3 in parentheses, it's to the 3rd power minus 21, all over 5 times that 3 plus 9. Now, a fraction bar is essentially a grouping symbol as well. You have to solve everything on the numerator before you can solve the stuff on the denominator. You cannot start canceling things out unless it's all multiplication, but we have addition and subtraction signs, so we need to treat the numerator as its own thing. So we want to say that 3 cubed is really 3 times 3 times 3. So that's 9 times 3, which is 27.